Once we get through all the properties, we'll have a couple quizzes. So,
There was no 90 degree in here though, right?
no, in the last one? No.
So why do you?
Oh, this one is, because the angle's 45 makes the center 90. So it's a switch, yeah. Okay, chord properties in our circles. So in this question, if we had time, I would give you guys all a ruler, and we'd take the time, and we'd measure the length of ST, and we'd find the middle of it. And we'd measure the length of EF, and we'd find the middle of it. And we'd measure the length of H and G, and find the middle of it. And then once we have those middle points, we would draw a radius through that middle point. Draw a radius through that middle point, and draw a radius through this middle point. So what we're doing right now to make us go a little bit faster so you have more time to work on homework in class is we're just going to say, I could do that. Do you think you have the ability to measure something and find the center? I think you would. Okay? Then what you would do is you would take a protractor. You guys know what a protractor is? One of these little things to measure angles. And we would have measured the angle in the middle of where these two lines cross. And we would measure one of them and find out 90 degrees. If you know that's 90 degrees, oh, this is another one of our properties. How do you know the one right beside it? If this one's 90, what's this one right beside it? 90, because in a straight line adds up to 180. If you know this is 90, how do you know the one opposite? Whenever they're opposite, they're the same. So all of these would be 90 degrees. And this is going to be true whenever you cut a chord in half and you draw a radius. So we show that it's cut in half by drawing a little dash there, dash, 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 dash. That's the mathematical way to say that two line segments are equal. And every time you do this, you will always make angles that are 90 degrees. So one thing that you can do to show that, instead of writing 90, do you know how the symbol for showing 90? A square. So sometimes what I do here is make squares all around, because all four of those will be 90. Same thing here. All four of those will be 90. How to find the center of a circle. So what that means...
Wait, you missed the fill in the blank.
Oh, sorry. Thank you. The perpendicular... If you make a perpendicular radius, which is 90 degrees, to a chord, it cuts it in half, and the math word for cutting something in half is bisects. So we have two things that we can now say. If you draw a radius and it cuts a chord in half, then the angles are 90 degrees. Or if you draw it at 90 degrees, you know that you will cut it in half. So what this means is if you ever want to find the center of any circle, what you could do is you could pick a random chord here, cut it in half, measure 90 degrees here, and draw a line through it. Then take another chord anywhere on the circle, cut it perfectly in half, measure 90 degrees on it, and you will perfectly find the center of any circle. Does that make sense? Where they intersect will always be the center. It is kind of cool. These are things that would have been used even thousands of years ago when they were trying to build really impressive buildings, thousands of years ago, like pyramids and stuff like that. It's kind of important to know where the center of it is. Because if you like you get to the top of your pyramid and like, oh man, we're off. Okay, everybody,
Restart.
take these stones off. Let's start again. Oh, that would not be very much fun. And it doesn't matter where you do this, right? If I started, oh, what happens if I start with this one? Ooh, from there to there. I cut it in half. I make 90 degrees with that. And then even if I take a little tiny one and cut it in half and make 90 degrees with that one, I will always find the center of my circle. Pretty cool. Check it out. Okay. I'm getting excited here. I am going to take a piece of scrap paper. Check this out. I'm going to take this and draw a circle. I'm going to cut this circle out. Fascinating. Okay. Did you know that if you take a circle like this and you fold a side down like that, that fold makes a chord? Okay? And then if I fold that perfectly in half and line it up, I will make a perpendicular bisector perfectly for that one chord. So you see what I did? I made a chord. Then I folded it over to make it perfectly in half. That cuts it in half. That made a 90 degree. Now I can go somewhere else, do the same thing. There, I made another chord. If I fold it in half, fold it in half, open it up, and that is the perfect center to that circle. Now, since that's the perfect center to the circle, that is the only place where you could put a pen. If I can see it. And balance it. Because it's very hard to balance a piece of paper like this on a pen unless you found the perfect circle. You like the eyes? Hey? Oh, look at that. That's pretty cool. With just some folding, right? Hmm?
Hey, don't diss the math.
Oh, hey, there you have a signed circle by me. Right? You can sell that on eBay one day for millions of dollars. I was in the class. There we go. Okay. Here we have our example. There you go. With only folding, find the place on the triangle that would do the same thing. Okay. In the circle with center O, C to D is 48. So from here to here, sometimes when I have longer lengths, I draw that little squiggly thing, right? Or just try, you've got the point? You can try to put your pencil there and see if it balances. Can't, yeah. No. Okay. O to M is 18. O to M is 18. Now, since they tell us in the picture this is 90 degrees, we have to now know what does that do? What does that say? If it's 90 degrees there, that tells us this length and this length are the same. Okay? So if that length and that length's the same, what are those lengths equal to? They're both 24. This is 24 and this is 24. Okay? That is what we can figure out based on the information. We have to say, how does that help us find the length of the diameter? Okay? Like there are an infinite amount of diameters that I could draw in here. There are an infinite amount of radiuses that I can draw in here. One of them is going to be helpful. Yes. M to O will only goes up to here, and it doesn't, this isn't necessarily cut in half. This perpendicular only cuts this. So it's a good idea to say, is it 36? The answer is no, because this doesn't necessarily cut in half. For example, if I had a chord here, you really would see that they're not perfectly in half. Do O to D makes a right angled triangle. And then we can put a little x here. And 18 squared plus 24 squared equals, oh, mental math, x squared. Anybody do this in their head? Come on.
18 squared, how much?
You don't even need to know 18 squared. I'll show you the shortcut for this one, but I'll do the long cut first. The long cut would be 8. That would be 324 plus 576 equals x squared. Add those together, you get 900 equals x squared. Square root it, and you get 30. Those numbers are all correct. I wasn't just making them up. Now, the shortcut for this one is to recognize that the triangle we have here is just a special version of the 3, 4, 5. The famous 3, 4, 5 triangle. What would happen if you made a similar triangle by multiplying all the sides by 6? If you multiplied all the sides by 6, you would get 18, 24, and, drum roll, 30, which also solves for that other side. Fascinating. They're all times by 6, right? Because this is similar triangle math. Cool.
I gotta remember
3, 4, 5. I find if you know how to count and you forget about 1 and 2, you got it down.
What's the other one? See, I was trying to remember your other one.
5, 12, 13. I'll give you some, if we have time, Mr. Shirk, at the end, I'll show you something cool with the 3, 4, 5, 5, 12, 13, and so on. Okay. So, you now know that x is 30. Have we solved the question? This is the radius. The diameter is 60. Did they give us any units? No. So we can just say 60. I like to write units when they don't give us units because it reminded you that you checked. You checked if there was centimeters or meters or kilometers. Oh, such a good unit. Question number 2. The circle shown with center O has a diameter of 20. So sometimes what I do when they tell us a diameter of 20, I right away break it down and say, I know this is 10 and 10. Two radiuses will both be 10. If chord AB is 8 centimeters from the center, so that means if chord AB is 8 centimeters from the center, then that tells us this is 90 degrees and this length is 8 centimeters. Find the length of A to B.
So we want to find
You want, yeah, you have to do the A squared plus B squared equals C squared. That would be.
I don't see any. Oh, good, good, good. So you want to, and this is something important in this unit. You can draw lines. And if you draw that line, that makes another radius, which is 10. Because these are all radiuses. And then we have a right angled triangle. What can you do with a right angled triangle? You can do A squared plus B squared equals C squared. This, if I call this little part here X, would that be a hypotenuse or would that be a side? And did anybody recognize that this was a 3, 4, 5 triangle again? Can you see it now? This is equal to, oh, sorry. I made a mistake. This is 64. 36, x equals 6. Can you see it's just double the 3, 4, 5 triangle? Then how long is AB? Yeah, because this is 90 degrees, you know that this side is equal to this side, so this side is also 6. That means AB is 6, and this time we have units. Oh, sorry, doubled it. Wow. AB is 12 centimeters.
Is that worded right though in the question? If
Is 8 centimeters from the center? Yes. So whenever you are measuring, like, for example, if I would take this point here and that line there, how far is that line from that point? And some people would say, well, it depends. Because if you walk this way, it's a long way to get there. But if you walk this way, that would be the shortest. So when we talk about how long something is away from a point, how long a line is away from a point, we'll always go at 90 degrees because that's the shortest. And usually when we measure something, we do measure the shortest distance. Like, how long is this piece of paper? You don't go, oh, I went this way. It took me a long time to get there. No, you would go the shortest way. It's so obvious that you look and you go like, that doesn't make sense. Right? But not very often do we talk about straight lines. Okay? But if someone said, how far am I away from the wall? Right? I could get to the wall if I walked there, but I would count the straightest, the closest distance. So and that'll always be at 90 degrees. Circle, center O. PA is 4. They tell us the angle is 90 degrees. Yes. They tell us the angle is 90 degrees. We need to find the length of the diameter. So can we draw an important radius here? Can you see that if you draw this radius here, is not the 3, 4, 5? No. This one doesn't work out nicely. If I put this a little x here, this is 90 on this side too. 2 squared plus 4 squared equals x squared, which gives us 4 plus 16 equals x squared. X squared is 20, and so x is the square root of 20. Oh, I was going to do it. 4.472. Okay. And so the diameter is 2 root 20, or 8.46. Do we have units?
You did that wrong. That math is
No,
8.46.
it's not 8.46. It's 8 point. What was the first one? The first one was 4.472. So this should be 8.946. Is it close? Okay. We'll just take that one out. All right. Example number 4. Now we start adding even more lines. And the question is, what is the length of CB? So this is what I want to find. And chances are there will not be enough information to figure this out yet. So instead, in a circle question, you don't necessarily go, how do I find that? Because then you'll get stuck every single time. Instead, you ask yourself, what can I find? And label that. And then ask yourself, what can I find next? And label that. And then ask yourself, what can I find next? And label that. And eventually, you will find what you're looking for. So, in this question, this is what I'm given. Because AE and EC have little lines on them, I know that they're equal, so I know this is also 8. And since they're equal, and DO is a radius, I know that all 4 of these are 90 degrees. Does that make sense? So that's our new property for today that we learned, that if a radius cuts a chord in half, they're all 90 degrees. Can you see that that makes a right angle triangle? And with a right angle triangle, you can do a squared plus b squared equals c squared. So 6 squared plus 8 squared equals a to o squared. And then if I do these, I get 36 plus 64 equals AO squared. And maybe you recognize this as another 3, 4, 5 hidden. 6, 8, 10 is another 3, 4, 5 times 2. So first of all, I knew that these sides were the same, so I knew these were 90. And then this made a right angle triangle, so I went a squared plus b squared equals c squared. I noticed this was just 3, 4, 5 times by 2. Okay? If I know that a to o is 10, I know that o to b is 10. And then Haley, it comes down to you. Since you've forgotten it twice already today, can you tell us what we also know in this picture? Yes. This is a central angle of 180. So what does that tell us? This is a 90 degree as well. That's the one that's hard to see. And if that's a 90 degree as well, okay, If that's a 90-degree as well, can you see that you also have a big right angle triangle here? And you know this is 16 and this is 20. So you can do 16 squared plus x squared equals 20 squared. No, but it's a similar triangle. It's another 3, 4, 5. But if you did it this way, you would get 256 plus x squared equals 400. X squared is equal to 144, and x is equal to 12. What was the question asking for us? What is the length of CB? So I would probably write that as my final answer in the end. How is that one for complexity? Again, what we have to do is we'll have to say, what do I know? What can I find out? And how do I go from there? All right, we have 2 left to go. I think we can finish them. Example number 5. In this circle with center O, what is the length of A to C? Okay. A strategy that we've used often is drawing in radiuses to make right-angled triangles. So can you see that that's going to be a good strategy? How long is O to C? 14, because it's another radius. Perfect. What else do we know? I know from here to here is 2. So what else do I know? No. I got a right angle. See, I have a right angle triangle. I want to use a squared plus b squared equals c squared. But right now I can't because there's 2 things I don't know on it. What? Yes. How long is this? 12, because this is a whole radius. And a whole radius is 14, and they tell you the one part is 2. So you know the rest is 12. And now I can find this length here, that 12 squared plus x squared equals 14 squared. So 144 plus x squared equals 196. X squared is equal to 52. And x is equal to the square root of 52, which is about 7.1, 7.2. So AC is equal to 2 times square root of 52, which is about 14.2, 14.3, 14.4. 14.42, thank you. Nice. I was getting closer. That's because I didn't know if this was closer to 7.1 or 7.2. And apparently it was closer to 7.2.
7.21.
So then timesing that by 2 makes 14.42. That's our final answer. I like to circle my final answers. And our last question. So how do we find the center of a circle? Two chords. Draw a chord. Cut them in half. Measure 90 degrees. Shoo. Another chord. Cut it in half. Measure 90 degrees. Phew. And there's the center. Excellent. It is someone shooting a bow and arrow. All right? It's what Mr. Shirk does when he gets home. Takes a picture of you from Power School. So tomorrow, you need to bring your textbook because now there's 2 homework assignments. The one that we ended at the beginning and the one here. And we are going to work on them during class. So what do you have to remember for tomorrow? Textbooks.